Good morning. Today in part 2 of our bracket video we're going to cut the counterbore holes and we're going to cut in the countersink holes. Both have a unique purpose, so let's get into it. Open our bracket back up. So a countersink is used to recess a bolt head. It has a flat bottom. It's a round hole, has a flat bottom. Allows a bolt head to come down and press on the lower part and then be recessed below this surface. A countersink has an angled surface to accept like a screw head. And so we're going to put those on this back surface right here. But to begin, let's work with this surface right here. So we're going to start a sketch on this surface. And I'm going to zoom in on that just a little bit. And if we go back to our drawing, we're looking at this piece right here. We're cutting this hole in, and we're looking at this rectangular piece right here. And so the dimensions we're looking for is 23 from the back and 16 from this right end, right here. So that's what we're interested in. Now, we could do this with circles. We could draw a circle and punch it through, and then draw a bigger circle and punch it partway through. But the proper way to do this is to select a point in your ribbon, find point, and I'm just going to randomly place that point. And then I'm going to dimension it into place from the point to the back was 23, and from the point to the side was 16. Now, that doesn't give us our holes. So when we finish the sketch, I'm going to zoom back in on this a little bit more, and go to hole, we get a pop-up box, and you see how that punches that hole through there. Now, as we come over to our type, we're interested in the seat. So you see we have a counterbore, a spot face, and a countersink. This hole is a counterbore, so we're going to select that. Now we need to go back to our plan and see what size it is. And if you roll down, get caught up here with where we're at, our distance across the larger part of the counterbore is 18 millimeters. The smaller hole is 13 millimeters, and this counterbore goes down 10. So if we go back to Inventor, and you may look, your pop-up box may look exactly like this. Your counterbore piece is right here. We want a straight, smooth hole, 18 on the top, 13 on the bottom, 10 deep. So when we come back to this, all of those dimensions are given to us right here. So we want to go through our top distance was 18. Our depth was 10. Not 210. Was 10. And it's not allowing me to select this size. I do want to go through. Now you see where that gave me a threaded hole. I don't want a threaded hole. That might have been what my issue was right there. I don't want a threaded hole right there. So if you do that, that's not correct. So we're going to come back over and edit the feature. I don't want a tapped hole. I want a simple hole. That was my issue right here. When you tap that, it puts the threads in the bottom. I want a simple hole. So now let's double check our measurements. 18 on the top, 10 deep. Now I can change this size to 13 and click OK. And now my hole looks proper. So you can see where that gives us a seat right here for a bolt head to sit down on to tighten down however this would be tightened down. So I'm going to right click and turn that off. So now we do the exact same thing on this surface. Locate a point, dimension it into place. Again, we were 23 down and 16 from the edge. That gets us in place. Finish the sketch, and you might want to turn this around so you can see what you're doing. Hole, and it should have held your information. And so double check it, 18, 10 deep, and 13, and if it is, then click OK. And that gives you both countersinks. Counterbores, I'm sorry. Gives you both counterbores. So now let's do the countersink. So we're going to start a sketch, and we're going to place these on this back surface right here. So we'll start our sketch there. I'm going to zoom in on this. Let's go back to our drawing, and we'll scroll down to see what our spacing is. So from the left edge, we're going to be over 23, and then the first point is going to be down 15. The second point is going to be down 42. So we're going to locate 2 points, dimension, and this dimension was 23. This dimension was 23. And then the first hole was down 15. The second hole was down 42. And I do want to just double check that, 15 and 42. Now, if we scroll just a little bit more, when you finish your sketch, you're going to select hole. Now you're looking for the countersink function. You do want it to be a smooth hole. You want it to go all the way through. You want the distance across the largest opening size of the top to be 20, the angle to be 90, which I think is a default angle, and the main part of the hole to be 13. So 20, 90, and 13 is what we're looking for. So we can finish. I'm going to zoom in, and I'm going to rotate back just a little bit so we can see both holes. We want to select hole, and now I'm looking for countersink. Make sure I'm on a simple hole. Our distance was 20 by 90, and was 13 correct? Yes. 20 by 90 by 13. And you see that puts both of them at the same time. You can see the angle where a screw would go through there, and a screw would fit on this angled surface and fit very nicely and pull down flush. So that gives us our 4 holes. So the next step, going back to our plan, is to just finish this up. Fillets are rounded features that help provide strength, helps knock off these square corners. And so we're going to round the corner on these lower sections, all 4 corners, and then we're going to round the bottom part of this slot. And our fillet size, the radius is going to be 12. So when we come back to our drawing in Inventor, you find fillet, it's looking right at it, find fillet, and you want to change your radius size to 12. And now as you start selecting edges, And you see we're just getting the vertical edge. I've got to rotate all the way around. Lost it. So I can see this back edge. I want that one right there. I'm going to straighten up, and now I want this one to round this off, and now I can't, maybe I can get it from right there. There it is. Apply and cancel. And let's take a look at that. See how that rounds that off nicely. All 4 lower corners. And then it softens this edge where a part will slide down in here to engage this bracket. Now, to finish this off, if you go back to your plan, the final fillets are applied to the rest of the surface to create rounds as needed for casting. The radius is 3 millimeters. So if you notice on this back edge on this upper part is not rounded off. It doesn't hurt anything, and probably from a finish standpoint, it's probably better if you do. So we'll just round everything else that we've got left here. So we go back to fillet, change our radius size to 3, move this out of the way, and literally we're just selecting every line. If you notice, you highlight that, it gets that entire U on the inside and on the outside. I want the vertical. Now you've got to rotate. I'm going to apply and cancel, and then I'm going to check and make sure. Now I did not do the bottom because I want this to sit flat on whatever surface it's going to be sitting on. But I do have rounded edges all the way around this. I have rounded edges all on the inside of the slot, and I have rounded edges on all of this. And so if you've got that done, that is a finished bracket. I'm going to shade this. I don't know that I want it to be a steel. Let's do a cast. That's awfully dark. But it does work. So if you do it as a cast iron, you can shade that, color it however you want to do that. That is your finished piece. 2 holes going all the way through. You can see your holes going through there. There you have it. Be sure that you save, do a file save, and that is your finished bracket. Be sure you let me see this, and we'll go from there.